Okay, today we are going to talk about how to write a proper physics lab report on the topic Hooke's law. Now, the thing to keep in mind is that the whole purpose of this lab is to determine the relationship between the applied force and the extension of the spring and or rubber. Things to include during the lab is that the force needed to extend or compress a spring by some distance is proportional to that distance. The formula we shall be using is the Hooke's law, which is Fs equal to Kx. The Fs being the spring force, K being the spring constant, and X being the spring compression. Now, a few things to note. The spring constant is a measurement of the stiffness of the spring. It is different for different springs and material. Basically, the larger that the spring constant is, the stiffer the spring and the more difficult it is to stretch. Another thing to keep in mind is that the constant variable shall be measured from the same spot on the ruler. The independent variable is the applied force, and the dependent variable is the spring extension.
Nextly is how to write a proper hypothesis. Firstly is to make a statement or prediction of which you want to talk about when doing a lab. Secondly is use the independent variable and dependent variable to guide you on making the statement. Nextly is to try to make it clear and use simple English, as you do not want your audience or reader to get confused of what hypothesis you're making. Hypothesis should be short and it should not be long. And lastly is to make sure your hypothesis can be proven when doing the lab.
So, how do you properly list all the materials that you use in the experiment in a lab report? So firstly is to take picture of the tools that you use during the experiment. Secondly is to label the picture with appropriate name and appropriate arrows to specific tool. Thirdly is to create a list of point form. Fourthly is to specify the number of tools you use in the point form. Follow up with the name of the tool. And lastly, after the name, to specify any specific measurements. For example, if there's a specific weight, that a specific mass that you wanted to take into account, or if there's a specific length to a certain object, that it's very important.
Okay, as you can see here, I'm starting with the spring 1 and I'm using the meter rule to get the measurement of the spring without any masses. And we are doing this 3 times and then getting the average. So to get as much as we can accurate data. And here Randy's taking the measurement because if I took the measurement there will be a parallax error which we're trying to avoid once again to keep the data accurate. As you can see here, I'm adding a 50 grams weight onto the spring and recording the new length 3 times to get the average. Lastly, make sure that the spring isn't bouncing to avoid error. Now repeat the steps again, but with 100 grams, 150 grams, 200 grams, 250 grams, and last but not least, 300 grams. And now repeat all the past steps with the same tools with the spring 2, the pink rubber band, and the yellow rubber band to get all the data needed for the lab. Also, to get the extension, you have to minus the new length from the length without any mass to calculate the extension.
Right here is the data collection guideline. This table can be placed into your spreadsheet to collect your data. For the data to be calculated, we will need to calculate the extension, which as you can see in trial 1, 2, and 3. and it can be calculated by the length of the mass at 0 kg minus by the mass used, for example 0.050 kg. The yellow bar shows you your uncertainties. The average in cm and the average in meters can be calculated by adding trial 1 to trial 3 divided by 3. As for the gravitational acceleration, you can use the acceleration of gravity, which is 9.81 meters per second squared. To calculate the force, we can use the formula F is equal to ma, where m is equal to the mass and a is equal to the gravitational acceleration. And as for the spring constant, we can use the formula F is equal to kx. Here are some of the graphs to be created. One of them would be extension versus the force, which is shown here. The spring constant versus the force, which is shown right here. And the extension versus the spring constant, which is shown right here. So how exactly do we write an analysis? In the analysis section, you will need to include the interpretation of your results, the comparison, your finding with your expectations, identifying any sources of error, explaining any unexpected results, suggesting possible improvements for further studies. For the interpretation of your results, you can interpret your findings, entail determining how they contribute to your answer to your main research question, report on if your findings back up your theories, and some of the questions to be answered would be: did you measure what you sought out to measure? And were your analysis procedures appropriate for this type of data?
Nextly is how to write a proper conclusion. Firstly is to include your aim for the lab report, as stated from your introduction. Nextly is to review the hypothesis or the prediction that you made that when you're working on the lab. Thirdly is to relate the results to the analysis, whether if the prediction that you got from your hypothesis is proven to be correct or proven to be wrong. Fourthly is to include possible sources of error, at which there may be parallax error of uh, our eye level not properly matching with the same level as the spring on the ruler, and that could be one of the possible sources of error when working on a Hooke's law lab. Fifthly is to include improvement in the future of how you can work on this lab to improve on and how to reduce the level of sources of error. And lastly is to relate a topic to a real life situation, explaining how Hooke's law can be found in our daily lives and how springs are used in many of our daily life appliances. Lastly is how to properly reference your lab report using APA format. Firstly, to use Times New Roman for the font. The font size should be 12 and the spacing should be double. For example, here we have a properly reference website, and whenever you're using a certain sentence that is from another website, you should have in-text citation. So how do you properly write in-text citation is that firstly to quote the sentence that you took from the internet, and you bracket and you put the author's name or the website's name if the author is not present, and you include the year which the website is published or which the article is written. These are the references for this research topic, and that's the end of our